So,
Okay.
I don't need to repeat everything that I said. What I need to do is make sure you understand what's a function and what's a one-to-one function. Got to be able to understand that, okay? So,
Okay.
I'm going to draw a bunch. Shoot. I keep drawing them in a way that you can't tell exactly whether it's one-to-one. So let me draw it a little better. Even that, boy, hold on. Can't be that tough to draw one-to-one. Let me see. There we go. Is the one on the left one-to-one? First of all,
Yeah.
is it a function? There's two kinds of things, Zach. There's a function and there's a one-to-one function. You have to know the difference. Is the one on the left a function?
Yeah.
Is the one on the right a function?
No, I don't think so.
Well, because I've drawn it funky here, let me erase it and draw it properly. The one on the right a function?
Yeah.
Is it a one-to-one function? Is the one on the left a one-to-one function?
I think so.
Because it passes the horizontal line test. In other words, no matter where I pass a horizontal line, I only get one value of x. Okay? Now, the one on the right is indeed a function. It passes the vertical line test. No matter where I pass a vertical line, I only get one value of y. Well, if we try to determine whether it's one-to-one, then I want to pass a horizontal line through there. Is there anywhere on this curve where I get more values than 1 for x on the pink lines?
No.
That makes it one-to-one. Okay? Let me draw one that would not be one-to-one. So you understand the difference. If I had a function, wow, that was weird. Let me think of a function. Is that a what's it got to pass for that to be a function?
The horizontal test, or no, the vertical test for a function. Horizontal.
Line test. Does that pass the vertical line test? Yes or no?
Yes.
Does it pass the one-to-one line test? No, because if I pass a horizontal line through that, I get that value and that value. So that's all you have to do is pass a vertical line or a horizontal line, and you'll discover whether something is a function. In other words, that is not a function. If I pass a vertical line test, it fails. And if something is not a function, it can't be a one-to-one function. So even though this passes the horizontal line test, it's not a one-to-one function because it's not a function in the first place. there a particular next one you want me to start with? I mean, what I'm going to try to do is look at all of these questions and see which ones are most appropriate to cover in the 40 minutes that we have left.
No, you can just take your pick, I guess.
All right. Let me have a look at this first before wow. Okay, let's see. Wow. They're starting at a degree of difficulty that is about twice as hard as your PreCalc trig course was. You understand?
Yeah.
Okay. So, if you have to take PreCalc trig over again, it's not a loss. It's just a harder PreCalc trig. They're definitely making this tough. You would not get this level of difficulty of questions. Okay. This is not multiple choice.
It may be.
No, it isn't. I can tell. Because they don't give you a question. In other words, they give you f of t and they give you g of t, but they don't ask you what f of g of t is. Okay? Each one of these is a separate question. So let's start with this one. What is e to f of t plus 1 equal to? Plug in f of t, the function, wherever you see f of t. So it's e to the what? E is a constant. E is a number, not a variable.
E to the 5t cubed plus 1.
Exactly. Plus another one, right? In other words, is all you did was plug in f of t for that. So it's really plus 2.
No, it's because it's a minus 1.
Excuse me. So it's plus 0, right?
Yeah.
So that's what the answer is for that first one. Okay, how about the second one? Add the first function with the second function squared. What's the first function?
5t cubed.
And then add to it the second function squared.
T plus 1.
What's the answer?
5t cubed plus t.
Perfect. Well, I don't know. You might have a shot on this test. You might not. What's g of t squared?
T plus 1.
No, just, in other words, what they're saying is plug in t squared wherever you find t. That's always the first step. Don't try to go to the last step. Plug in the first step. So it's the square root of what?
T plus 1.
Well, wherever I find t, I'm going to plug in t squared. That's what it is. That's the answer. It's not t plus 1. The square root of t squared plus 1 is not t plus 1. If you square t plus 1, you will realize you do not get t squared plus 1. You get a middle term. So this is the final answer. Okay?
Okay.
The key is whatever is inside that parentheses, you plug in wherever you see t. It's that simple. It really is not that hard. All right, what is f of 2t? Go to the f function. Just lay it out. Don't try to simplify it in one step. Lay out the first step. The first step is extremely easy.
5 times 2t cubed.
Rest of it?
Minus 1.
That's it. Now, they might want you to simplify that, so simplify that. What is that? What's 2t squared? Or, excuse me, what's 2t cubed?
8t.
8t cubed.
Cubed.
You have to cube both that number and that number, or that variable. So it's 8t cubed minus 1. Very simple. Whatever's inside the parentheses, plug in for t and simplify. It's really not hard at all. This is one of the more simpler concepts in algebra, is that when you have something inside the parentheses, you take whatever it is and you plug it in for t in the original function. That's it. And then you simplify. I'm going to jump around here. Some of these questions I don't think are terribly useful for you, if you don't mind.
Yeah.
I'm going to go to the next one, which is this one. And I'm just going to kind of scan all of these problems and see what I think is appropriate. I mean, we only have 30 minutes, so. Hold on. Sorry. So, if we know the zeros, hold on, of g of x are minus 2 and 3, what is g of x equal to? What are the two linear factors that multiply together to give you g of x? X plus 2 and x minus 3. That's what the zeros mean. Okay? It means that if I had this and it was equal to 0, what would the zeros be? Minus 2 and 3, right?
Yeah.
So what they're wanting you to do is go backwards. That's it. They give you the zeros. They want to find the original function. Well, g of x must be a quadratic x plus 2 times x minus 3. That's what g of x is equal to. Okay? Now, what are the zeros of that? Well, first of all, what is y equal to?
G of x times g.
No, it's equal to g of x plus 1. Well, if this is g of x, what's g of x plus 1? What do?
Wait, why is it g of x plus 1? Oh, I see. Okay.
Because that's what that says. That's what we need to figure out, is what is g of x plus 1? Well, we figured out what g of x was. So what's g of x plus 1?
x plus 2, x minus 3, and then plus 1.
What? No. What do you do? What's the rule when you have a complicated expression inside the parenthesis?
Distribute.
No, you plug it in wherever you see x. Okay, well, here's an x right here. So it's x plus 1 plus 2 times x plus 1 minus 3. That's what g of x plus 1 is. Now simplify that. What's x plus 1 plus 2?
3, or x plus 3.
Okay. What's x plus 1 minus 3?
X minus 2.
Multiply those two together.
X squared. X, or, what should we call it? Yeah, just x, right? I think.
Plus x. Cannot ignore the plus sign there. If I were to do this, if I were to do it the way you told me to do it, which is the plus, or you just said x, that's what I'd be looking at. And that has no meaning. Without the sign in front of it, it's not a polynomial. I need the plus sign. Sometimes you need the plus sign, sometimes you don't in math. In other words, I don't need the plus sign in front of the x squared, but I definitely need the plus sign there. Absolutely. And what's the last term?
Minus 6.
Okay. So that's what g of x plus 1 is. They don't want g of x plus 1. It's not an easy test. They want 2 times g of x plus 1. So what's 2 times x, g of x plus 1?
X to the 4th plus 2x.
Multiplying by a constant. You're not multiplying by x squared. Multiplying by 2. In other words, there's a 2 in front of that. 2 times g of x plus 1 is equal to 2 times whatever function we came up with.
Okay, 2x squared plus 2x minus 12.
That's the answer to that question. Now, none of these are easy. They're all tough. Okay? So, I don't know. All right, let's look at 17. This is a very critical problem also. This is definitely something you need to know. This is a basic, simple composite function. That means it's a composite function. Okay? It's a combination of two functions. So, what's g of x? This is the way you always start these. Is you start by filling in g of x. What's g of x?
4 over x squared minus 1.
Okay, so that's what we're looking for. We're looking f of 4 over x squared minus 1. Now let's go to the f function. What is that equal to?
3 over x.
No. Remember what you do.
Oh, okay, so it'd be 4.
Inside the parentheses, and you substitute it for this x.
Yeah.
Okay, so what is it?
3 over 4x squared minus 1.
4 over x squared minus 1. This is complicated. It's a numerator over a denominator that has a fraction in it. Okay, and what else? We didn't put in the minus 1. Oh, yes, we did. Okay, so that's what we're looking at. Okay, that's what f of g of x is. The only thing is we haven't simplified it. So let's simplify it. This is just algebra, but it's definitely algebra you need to know. But we need to simplify that. That's if you had a multiple choice, that would not be one of the choices. How do you, whenever you're trying to simplify this, when you have two fraction bars, in other words, you have the main fraction bar, and then in either the numerator or the denominator, you have another fraction bar. Well, you have to simplify that to begin with. I cannot flip and multiply until that is simplified. So what does the bottom simplify to? What is 4 over x squared minus 1 equal to? How do you do that math?
You multiply 4 to each side.
That's not an equation. That's an expression. How do you subtract a number from a fraction? That's what you're doing, is you have 4 over x squared and you're trying to subtract 1 from it. Whenever you're adding or subtracting fractions, you always have to do the same thing first, every single time. What is it?
Common denominator.
So what's the common denominator going to be?
X squared.
Okay, so that's already that. What's 1 equal to? And if I put a common denominator of x squared there, what's the numerator?
X squared.
Okay. So now that whole expression, I'm going to go here in the upper left, is equal to 4 minus x squared over x squared. Okay? Now, let me erase all this other stuff so I got some writing room. Unfortunately, I got to go at 1 exactly today. I have another student at 1. So I'm going to have to kind of pay attention to the time.
Okay.
Okay. So here's what I got. I got 3 over, here's the large fraction line, 4 minus x squared over x squared. How do I simplify that?
You multiply by the reciprocal.
Okay, tell me what that is. Tell me how to lay it out. 3 times what?
3 times x squared over 4 minus x squared.
What's that equal to?
3x squared over 4 minus x squared.
That's the final answer. I cannot simplify that. You understand why the x squareds can't cancel?
Because one's being multiplied and one's being subtracted.
Exactly. There's a number that it's being subtracted from in the denominator. The only time you can ever cancel them is if they're both multipliers. In other words, if I had an x squared multiplying that, well, then I could cancel that. But I don't. So I cannot do that. Okay. So that's the final answer. So that was a doable question. In other words, you definitely want to know how to do 17. Every day, every hour. And it does not matter how complicated that is. You can make it 5 times more complicated. You should still be able to do the problem. It's merely a question of saying, start out by what is f of g of x? Well, g of x is that. So I'm going to start out by substituting that. And then what's f of that? Well, I'm going to take that and substitute it for that x right there in the f of x function. All right, let me go up a little bit here. Let me look at some of these before we tackle them, because not all of these problems are equal. This is actually a pretty good problem here. Let's do this one. It's a good problem because it illustrates something that is difficult. Tell me what transformation is going on there.
It's going up 4 places.
What's the minus sign in front of the f of x do?
It's reversing it, kind of.
It's reflecting it over which axis? You need to answer all of those questions.
Over the x-axis.
Okay. So if I reflect that, and you do reflections first, always. If I reflect that point over the x-axis, what is it? In other words, that point right now is 2 minus 5. Reflect that point over the x-axis. Where does it go to?
Like infinity, maybe?
Reflect it over the x-axis.
So it'd be...
It's about right there, right?
2, 5.
Ah, exactly. It's really simple. In other words, the x-axis does not change, but the y-axis takes the opposite sign. Now add 4 to that point. Remember, you're adding 4 to the y value. It's this y that's having 4 added to it.
So you have to move the point up 4 places.
Okay. What's that coordinate?
2, 9.
That's the answer. This part. Again, I will put my 2, negative 5 point on there. And, get in the habit of drawing these graphs, because that will clarify it for you. It really will. In other words, you learn a lot by drawing that point. What's the 1/4 do? Does it affect the x value, the y value, neither, or both?
Both, I think?
No, it doesn't affect the x value. The only thing that's affecting is the y. In other words, the y becomes 1/4 x instead of x. So what's the new y value become? X value doesn't change. What's 1/4 of the y value?
And it'd just be -4, 1.
It's 1/4 of that circled value there.
Oh yeah, we're still using that point.
X value does not change. It's only the y value that changes.
It'd just be -5/4.
You got it. It's easy to figure out. You just multiply the y value by 1/4. In other words, if you're not sure, plug in 2 for x. When you plug in 2 for x, you still get an x value of 2, but you get a y value of -5/4, not -5. Okay? In other words, these transformations, some of them work only on the x, some of them work only on the y, some of them work on both. Let's look at this one right here. I'm again going to put my point on there. That 2 comma minus 5. Now, if I multiply that in, well, always do your negative signs first. So what's that? What's f of negative x?
It would be -2.
Yeah, very good. In other words, that point is -2 minus 5. The only thing I'm working on is the x value. The negative sign is inside the parentheses, operating on the x value. That is a reflection over the y-axis. When you see f of minus x, that's what it is. If you see minus f of x, that's a reflection over the x-axis. But if you see f of minus x, that's a reflection over the y-axis. Well, if I take this point and reflect it over the y-axis, I've drawn it a little funky here. It goes right there, okay? Same label, but the location needs to be a reflection over the y-axis. So that's f of minus x. Now what's 3 times that? It's one of 2 answers. Do you multiply the x by 3 or do you multiply the y by 3?
The y.
Okay, what's my answer?
-2, -15.
You got it. They are not getting any easier. However, this is also a pretty important problem. So we need to do it. Let's try to get through this problem before we sign off. First of all, if you remember, there are 3 different formulas for growth. And just to review, there is, hold on a second. There's this one. That's annual growth, annual compounding. There's this one. That's growth at some interval greater than yearly. In other words, like monthly growth or daily growth. Okay? And then finally, there's a third one that really is what rules the world. In other words, most every natural process in the world does this. Operates off of that model there. Now, when they tell you it is predicted that population will double every 25 years, which growth do you think we should use here? Which of the 3? This is annual. This is greater than annual, in other words, like monthly. And this is continuous, much greater than annual. That's every single second it grows based on the formula.
So annually.
Look at question B. Don't look at just question A because they don't tell you. Oh, actually question A asks for annual and monthly growth. So this question requires you to know all 3 of these because the third one is continuous. So there's annual, there's monthly, and there's continuous. So another problem where the most important thing you can know is the formulas. Math is all about knowing general formulas and then just plugging in. Okay? If you know the general formulas, the problems become easy. So let's look at the annual. Okay? So the annual says that the amount is going to be the initial amount. Well, it doesn't matter what the initial amount is. All they've told us is that it doubles. So I can make any initial amount I want. Let's make it 1. I'm investing $1. Okay? And it's got to be 1 plus the rate to some time period. Now, determine the annual and monthly growth rate. Well, the annual rate should be pretty easy. If we're doubling every 25 years, fill in the missing variables for this equation. And it doesn't really matter if I start with $1 as my initial investment or $10 or $15, you'll see why. I'm going to start with 1 because that makes it the easiest to do the math. So if it doubles every 25 years, fill in the variables for me here. What's y going to be equal to in 25 years? This is what you started with.
It's going to be...
You got it. Say it. If it doubles, what does the 1 become?
2.
Okay. So 2 equals 1 times the rate is what we're trying to figure out. We don't know what that is, but they've told us 25 years. So now I have an equation with only 1 variable. How do I solve that equation? First of all, I can get rid of the 1, right? Don't need this 1. Now, how do I solve that equation?
Take the 25th root.
Perfect. 25th root of 2 is going to be equal to what?
1 plus r.
So what's r going to be equal to?
25th root of 2 minus 1.
Outside the radical sign. So that's what the rate is for annual growth. Okay? In other words, if everything's growing at this formula up here annually, well, that's what the rate is. The 25th root of 2 minus 1. And you can get that number out of a calculator, but the number isn't important. This is what's important. You can always get that number out of a calculator, but you can't always get the setup out of a calculator. And the setup equation is the important one. All right. We're going to have to call it a day.
Okay.
Okay. Zach, good luck on your test tomorrow, but don't be discouraged. If they put you in PreCalc, do not be discouraged. You need a semester of PreCalc trig. You do. In fact, you're going to be better off that way. If you were to go straight into calculus, you would never cover this PreCalc trig stuff. They're giving you the hard version with these questions, but you got to know the hard version. You can't really understand calculus unless you really understand PreCalc and trig. And so I'm not going to be that disappointed if you get put in that first class. In fact, I think that would be the best thing for you. What are you majoring in?
I don't have a major yet, but if I want to contract with ROTC, you pretty much have to do something in the STEM field.
I was going to say it's going to have to be engineering, huh? That's what ROTC at Colorado School of Mines was. It was all engineering core. So you had to pass certain math exams. So there's no doubt in my mind that you need a semester of this stuff. Okay? So do as well as you can on the test, but don't be disappointed if they put you in the first class. That will be actually good for you.
Okay.
All right. And I'm happy to help you. You might need help because the pre-calc trig that they're going to give you is going to be hard. It's going to be college pre-calc trig, which is a little harder than high school pre-calc trig. So you might need some ongoing assistance even at pre-calc trig. And I'm always available. So Zach, talk to you next time, whenever that is.
Okay.
All right. Bye-bye.
Thank you.